All right, welcome everybody online. Welcome everybody coming in person. It's great to see some new faces. Welcome to Flutter Atlanta. Just before we get started, just so y'all know, this is being live streamed to YouTube, and we are using the mics in the ceiling, so they can't see you, but they can hear you, so don't say anything that you might regret. And yeah, if you want anything from the recordings, we have a YouTube channel, Flutter Atlanta, so you can always find everything recorded over there. First off, my name is Emmett Dean. I am an engineering manager here at Black Airplane, and I lead the Flutter team here. I have a background in native Android and iOS development. I've been using Flutter for over 3 years and built over 17 Flutter apps, and I love it so much that I also use it on my personal projects. I want to give a quick shout out to Black Airplane just for letting us use this awesome space and hosting, as well as for the food and the beer. Black Airplane is a leading development agency in the Southeast, and we have a special team that produces top quality work, and we're capable of producing pretty much anything these days. So if you can dream it up, we can build it. Today we're going to be talking about how widgets are rendered in Flutter. So first off, what is a widget? A lot of people in Flutter, when you're getting started, they'll just say everything's a widget, because when you first get exposed to it, that's truly how Flutter feels. But in reality, a widget is an immutable description of part of a user interface. So let's take a look at the code. We have even up here in the widget, in the actual source code from Flutter, this immutable tag. This might actually pose a couple of questions to you once you see this. If my UI is immutable, then how am I going to actually update the UI to show different parts? Or how is Flutter going to manage state? Well, the way Flutter renders out, they don't actually just have one widget tree. The widget tree is what we're exposed to when we're writing Flutter code, but there's actually 3 different trees in how Flutter renders out their UI. So we're going to dig into these 3 different pieces today. The widget tree, the element tree, and then the render tree. So what is an element? While the widget is a immutable description of a piece of UI, an element is an actual instantiation of a widget at a particular location in the tree. And what is a render object? A render object is actually the source of information for drawing user interface components. Render objects are typically really expensive to start up and destroy because it holds so much information about how you actually lay out the logic. So part of using these 3 trees will actually get us some performance gains, which we'll see in a second. The next, a lot of graphics I've taken from flutter.dev, so we'll kind of walk through this whole process of how UI actually gets rendered out on the screen. So first, let's look at the 3 sections. We have the configure. This is basically going to be your widget tree, and this is meant to hold properties and offer a public API that we're able to interact with. The middle is the lifecycle, or the elements. This is to hold a spot in the UI hierarchy and manage parent and child relationships. And then lastly, you have the paint, or the render objects. And this is to size and paint itself, lay out children, and also to claim any input events. So if you were to look at this in a practical example, if you had a widget that was just called foo, it might have another class called foo element, which is the element representation, and then render foo, which would be the render object. And again, this is going to hold the configuration for a piece of the UI and have a public API. This is going to represent it as a piece, or the actual piece of the UI, and holds references and manages the trees. And then the render object is actually going to know about the size, the layout, the painting, and any other compositing things that you would have actually at the paint time. So let's start to walk through a real life example of how this would work. So at first, we have our widget tree, exactly how we built it in our code. In this case, it's just a center widget with some text that just says, hello world. At the start of the app, it's actually going to use widget.callCreateElement. And then you're going to create this first element. In this case, it's a single child render object element. They did not name these things, very easy to talk about in presentations, but basically all this is saying is this element refers to a widget that is going to have one singular child, which is going to be, in this case, our rich text. Then, with the element, it's going to go ahead and create the render object. This is the expensive operation, where it's going to store all of that different data about the size and all of the painting and everything that goes on there. And in this case, it's just a position box, because a center, all it's doing is basically telling you where exactly to put it in the UI. Next, it'll go to the next portion in the tree, and in this case, it's going to create a leaf render object element for our rich text. and then it will also create its render object, which in this case is a render paragraph with the text hello world. So as you can see, it kind of goes through this tree hierarchy, and we start with the widgets. It creates the elements, which creates the render objects, and then it goes deeper and deeper into the tree until we have everything built out. And as soon as the render objects appear, this is about when it's going to show actually on screen, because then it is paintable. But what if something in the UI changes? Well, Flutter will actually use this comparison that you can actually see with the keys and then also the runtime type. So let's just say we wanted to change our text to Hello Shanghai. So we replace these two widgets with center and rich text. Because center and center are the same type, and rich text are the same type, even with different parameters, and the keys, we're not using them in this case, so we can assume they're the same, it will actually remove the old widgets from the widget tree, and it will instantiate them and then link them to the existing elements. What this is allowing you to do is we no longer have to go and create brand new elements, which are therefore going to create brand new render objects. So we've just completely avoided this expensive operation of creating new render objects by being able to use these comparisons and just link the new items to the tree. But what happens when we link rich text, which now has a different value? You'll actually call a method, which is element.update, to update with all of the different variables that you have set in the new widget, which will then result in the render object getting updated without having to create one from scratch. It will only update the variables that changed. So this was a very quick talk, but in conclusion, this basically allows Flutter to manage state without having to recreate the most expensive elements. And this allows for rendering and re-rendering of only specific portions of the UI that you're changing. And this is what makes Flutter so capable when it's compared to other frameworks, by able to have extremely high refresh rates, because we're avoiding the most expensive operations as much. I know that was quick. I'm going to go back to the main tree view here. And do we have any questions?
Is that just during development? Is that like runtime when you've got it up on the
Yeah, so this is runtime. So during development, the only tree you are really interacting with here is this widget tree. And this is that declarative UI that you're writing in your Dart files in the build method. So where you're writing the container, which has a row in it, an image, and a text. Yes.
So in the context of, let's say you've got a widget that has, probably compound information in it, multiple strings of some sort. You make a call to a GraphQL API, comes back with different data, which doesn't match the immutable object that you had patterned in the widget. How does that play into this process?
So with your GraphQL, you have the business logic completely separated, right? So whenever let's use Flutter streams for an example. So you're listening to a data source, and then it changes. On the change, we have some sort of callback. A lot of times this could return a new widget. So like if you're using a stream builder in Flutter. So when it returns that new widget, even if it's the exact same type, we can look here, it does this comparison to see, okay, in this spot in the tree, we now have a different widget of the same type, so that means we need to get rid of the old instance of it. And because we're creating a new immutable instance with all of the new fields, we just need to link it to the element.
So you're basically recreating a brand new instance of the immutable object.
Yeah.
Okay.
And because the object's immutable, it's a lot more efficient to just replace these objects, and we also can carry way less data.
It smells a lot like object-oriented class inheritance situations in here of this process, right?
Yes, yeah,
Okay.
definitely. And again, for most Flutter developers, all of this element tree and the render tree kind of happen under the hood. And because of this abstraction that they do here, they're then able to go to their platform-specific systems and say a render image on web will be handled this way. A render image on iOS will be handled this way, because they have to interop with different programming languages and Canvas systems and things like that. So this abstraction allows you to handle that.
Okay, so during the development process, you're focused on the widgets and its relationship with each other, the widget tree. During runtime and debugging, you're probably looking more at the element tree and render tree, is that correct?
Yeah, you probably as a Flutter developer have seen if you don't give a column constraints or you put something in the column that overflows the constraints, the actual error that you're getting is based on the render object, because the render object is what's actually holding all of that painting information and the size that it's supposed to fit in, or if it doesn't have any constraints. So when you see those errors, you're looking at this, and then the nice stack traces actually will point you back to the widget that's causing the problem. And the element has those connections where the element knows about the widget and the render object, but the widget doesn't directly know about the render object.
Right, right.
Any more questions?
Yeah, in the case of like deploying to iOS, you know, I've done native where you're going in and setting up the constraints and, you know, all those minutia, right? Now, in this, if I do a Flutter, do I get into any of that, or is it part of the, you know, when it's creating the native version of it, it's handling all that for you?
So Flutter does not actually create a native element at all. So this is a little bit unique compared to React Native, from my understanding. We'll actually create real native elements using React Native code. Flutter is unique in the sense that it uses a canvas everywhere that it deploys to. So it is not actually creating an element. It is drawing every pixel, pixel by pixel, and then using gesture detection to relate it back to whatever you're trying to interact with on the screen. And it's impressive when you think about it like that because they've pulled it off very well. It's able to mimic really high-end experiences on Android, iOS, but also web and desktop now. Anything that has the capability for a canvas, Flutter can theoretically run on. Whether the runtime exists yet or not, it could be adapted for that.
And very negligible latency from your experience on things like that?
Yeah, the performance is extremely impressive. A lot due to this. We're negating having to do the most expensive operation as much as possible. So you can have Flutter running at 120 frames per second on 120 Hz mobile phones. It's actually extremely performant. And depending on the platform, it's either excels or lacks a little bit. But. Any other questions? I know this was a lot really quick.
Is there any tricks or things to worry about as the situations get more complex? I mean, this was kind of a simple instance of certain things, but the hairier things get, do you really have to worry about certain things, or it's more of a question of style and organization that
Yes.
kind of ties back to efficiency?
Yeah, I think there's a lot of gotchas that you should keep in mind. The most important reason you should understand this really is to know when your widgets are rebuilding. And there's different things that will cause your widgets to rebuild. But here, you're only making this state change if you're providing a new widget to then relink to this element tree. So there's a lot of things that you'll see that they'll look out for on technical interviews. If you are building out a large widget and you start breaking it down into methods versus separate classes that are their own stateless widgets, that's not a great thing, because if you rebuild anything in that massive widget, the whole thing will rebuild because the method runs every time. It's a method. If you've separated it out into a different stateless widget class, then it's treated like its own widget in the widget tree where it's now doing comparisons to see if it changed with the element. So there's things like that about understanding what is going to trigger this change in your code is going to really help you to debug your state issues of, okay, I changed this variable, but my UI didn't reflect that I changed that variable. What am I not triggering to surface this new widget?
I don't want to leave Randall out. He's got a couple comments in there.
Can you read them off if you find them?
Yeah, some are contextual. He mentions Boxy package. Have you worked with that?
What was it?
Boxy, Boxy.
I have not. A layout package to help you build different Flutter layouts, it sounds like. Can pull it up.
Has anyone heard of that?
Yeah, it looks like it's meant to just help you build different types of layouts.
But okay, just scroll back down to where you have like each one of those boxes would be considered a widget in the context of this flow.
Here? Correct, yep.
Okay.
But maybe we should hop into some code real quick. Let me spin up a project. Why not? We'll just open a new file. So, for example, if I were to build out a stateless widget here, and let's just say a very common example of this might be a list view, right? So I have a list view, and let's just say an item count. Let's do list view.builder. Maybe you have an item count of 10. We're building out 10 items. Item builder. And then I have some widget in here that's going to be reused for all of these items. So in this case, you know, it's this, we'll just use this for the example. You have some card that has a list tile on it, and then all of this different text. And it used to be very common that people would extract this to a method, right? It would make sense to try and just make this a little more organized. I don't feel like this is so complicated that it would need its own file. That feels like a lot. So a lot of people got in the habit of doing this private build item. But as soon as this data changes, now I'm going to have to rebuild the entire list of all of the items because this is a method. So as soon as the item count changes from 10 to 9 here, this is a different widget, and it's going to rebuild this entire list, which means it's going to rebuild all of the items. But maybe I'm listening to a stream and only one field changed on one item. So it's still going to call this item builder, and it's going to surface all of these widgets that are exactly the same, so there's no state that needs to be updated, and then it would only build this if it was a class. So let's go back. And there's still a built-in really nice thing for this. You can just do refactor, extract widget, and say like list item, and it will actually extract it to a class in that same file for you. And this is better if you don't want this to rebuild when the larger class rebuilds. There is still some times where that might be an advantage, but if you're getting to something so big that you want to consolidate it, make it more readable, then you should break it out into more widgets.
Can you talk a little bit more about other ways to get a widget to rebuild?
Sure. Do you have anything in mind?
Like keys are the thing that comes to mind.
Yeah, so again, the thing that we mainly talked about was the runtime type. But if we look at this, and you'll see, just close it out, but if you have any shortcuts like this, it always adds in this key. It's really good practice to override the key, which basically will allow you to specify a specific item. But if you go into the actual widget class, you will have this key. And there's actually great documentation right there in the Flutter source code if you want to read it. But this will control how one widget replaces another widget in the tree. So the first is if the runtime type and key properties of the two widgets are equal, respectively, then the new widget replaces the old widget by updating the underlying element. And it's calling the element.update there. So if you were to replace, let's go back. So if I were to give this a key that was just random every time, it would treat this as if it was an entirely new widget versus replacing the old widget, which would give you a different outcome. You can also force widgets to update by changing their key, which might be something that you would look at. So if for whatever reason your state management is not cooperating with you, or you need something to rebuild on some weird situation where the value isn't necessarily changing, or it's inheriting it from somewhere else, you could theoretically give it a different key and rebuild that widget just by changing. Does that answer your question? Is that what you were going for?
That was it. Thanks.
Does Randall have any more questions? Anyone else?
I have a question on the editor. Is that extract function strictly a VS Code thing, or is that
It should also be built into Android Studio.
Android Studio?
So Android Studio is the IntelliJ version of for Flutter. You'll just need the Flutter extension installed, and it should have all of those nice refactoring.
Okay. I've got Dart installed on PHP Storm since I use it all the time.
So if you use PHP Storm, it's an IntelliJ product. So if you switch to Android Studio, I think you'll be able to import all your hotkeys,
Okay.
and pretty much everything will be the same for you there.
Cool.
Any other questions? Awesome. Well, thank you for everybody that tuned in online. After this, we're heading to Reformation, so if you stick around while I pack up, we'll go get a beer, talk shop, and everyone online, come in sometime. You're missing out. Next time, we'll be talking about Google Analytics and using it in your Flutter app.
There was an open job. I sent Emmett the link and we'll post it on meetup.com. So someone's looking for a Flutter engineer in Raleigh, but I think it's remote.